Welcome everyone. In this video lecture, we will solve a problem based on the operational amplifier. And this problem is from Microelectronics circuits book. So the question is, the internal circuit of a particular op-amp can be modeled by the circuit shown below. Okay, this one is the circuit model of an op-amp. And so we have to express V3 as a function of V1 and V2. So what we have to do, we have to express v3, okay, as a function of v1 and v2. Okay, this we have to do. And for the case gm is 10 milliampere per volt, r 10 kilo ohm, and mu, the constant mu value is 100, and find the value of open loop gain, that is our a. These two things we have to find. So first of all, from this part we can easily say, the by analyzing this part, okay, means we can say this v3 is simply our v3 equals to mu times of vd. This v3 is mu times of vd because this one is also a voltage quantity, so this voltage v3 is same as mu vd. So what I am writing, this v3 is mu times of vd, say equation number 1. Okay, this portion v3 mu vd. Now next, the main thing we have to find now, that is our vd. So what we have to find, if we have the value of vd, we can put in the equation 1. So vd we can find from this one. So here we can say some current, that is our I current, is flowing from this side. Okay, that I current is going like this, and some current gmv1 in this one. Okay, and some current is going in this direction, gmv2. Okay, or we can also write same thing, gmv2 and gmv1. Okay, so from this circuit we can find the I value. Okay, so what I am doing, what we can do from this one, from this portion. Okay, so from this portion, okay, from this portion what we can do, we can write the current I, the total current, incoming current at this point, that is our point A, incoming I. So incoming current, this I plus GMV2. So one can write GMV2 equals to GMV1. Okay, and this one is outgoing. So this I equals to this one. You can easily write from this side. Okay, so from here now we can directly say the value of I will be GM V1 minus V2. Okay, so now this current is GM V1 minus V2. So now what I am doing, I is known to us, so we can say the VD value. So, but before that, this one is grounded and this one is say R, and this value is plus or minus VD. Okay, and this current is say I. Okay, so I is flowing from this side. Okay, so this I current is flowing, so it should be 0 minus Vd by R, lower potential minus higher potential. Okay, so this Vd is simply our minus I R. Okay, Vd is I R. This one is, say, this one is question number 2. Okay, Vd equals to IR, or one can also do, means if we take this as this kind of thing, and if we apply KVL or Kirchhoff's voltage law in this loop, so we can write plus Vd and opposite direction current, so plus I R equals to 0, so Vd equals to minus IR. Okay, the same expression we are getting. So this is the way, means simply 0 minus Vd by R. Okay, if we take this as a loop, okay, and plus Vd plus opposite direction no, so means on the this direction, so plus IR equals to 0. So this one VD equals to IR. So the value of VD we can write as VD equals to minus I. Okay, so minus R V1 minus V2. Okay, and GM will be there. So one can write GM R V2 minus V1. So VD is now known to us as a function of this one. First we have to write this one V3 equals to mu VD. Okay, from this one this value will be same as that of this one. Okay, and here this current I current is incoming current, and this one is the incoming current and outgoing current. So we can write this expression. Okay, so simply we can write this one equation number 2, and then if we apply KVL in this side, okay, this side KVL, okay, so then we can write this equation, or simply this current is going like this 0, so 0 minus VD by R. Okay, because this is lower potential but current is going from this, so this one is the expression. From that we can, after putting I value from this, okay, what we did, this value I value is put it here, so we can write VD equals to GMR V2 minus V1. So now VD is known to us, so V3 we have to write, so V3 expression, V3 is simply mu VD. Okay, so mu GMR VD is simply V2 minus V1. Okay, so one more line I am writing, V3 mu GMR V2 minus V1. Okay, now we have to find open loop gain. So A will be our V3, the output voltage by the this differential voltage, it is our V2 minus V1. Okay, and this value will be mu GFR. So in the question mu value is given 100. Okay, you can see the value is 100. Okay, R value is 10 kilo ohm and 10 milli. GM is 10 milli. So 10 into 10 to the power minus 3, and this one is R value is 10 kilo ohm. 10 kilo ohm. 10 to the power 3. It should be cancelled out. So it should be 10 to the power 4. So A value will be 10 to the power 4. Now we have to write gain in dB. Okay, so one can write simply 20 log 10 base A. So this would be 20 log 10 10 base 4. So it should be 20 into 4, 80 dB. Okay, so the final answer for this one, the gain will be 10 to the power 4, and gain in dB will be your simply 80 dB. So and V3 is already fine as a function of V2 minus V1. So mu GMR V2 minus V1. So it is very simple question, but we have to know the idea, means how to solve. So there is no need to worry about this V1 V2. Only this circuit and this part will be helpful to finding the open loop gain. So finally I am just writing the one more time the answer. A value in dB will be 80 dB. Okay, or this is 10 to the power 4 in unitless quantity, so 10 to the power 4, and the value of V3 is mu R GM V2 minus V1. So this is all about this question. So it is a simple question, but we have to know the some basic idea on how to solve. So this is all about this question. So thank you for watching this video.